Clock is illustrated in the diagram below. The clock face has a radius 12 centimeters with both minute hand and hour hand. 12 centimeters. 12 centimeters. The time shown is 6 a.m. The bottom of the clock face is located 4 centimeters above a horizontal bookshelf. So this h equals 4 centimeters. Write down the height of the end point of the minute hand above the bookshelf at 6 a.m. 12 plus 12 plus 4 is 28 centimeters. 28 centimeters. The height 8 centimeters of the endpoint of minute hand above bookshelf is modeled by the function. Theta is the angle rotated by the minute hand from 6 a.m. Find the value PQR. This P is amplitude. Q is dealing with the period. So Q equals 360 over period. This R is a midline. We need to draw the midline first. From ground to the midline, it's 12 plus 4. So R equals 16 centimeters. From midline to the maximum or from midline to the minimum, this is a radius, will be amplitude. So P equals 12 centimeters. How we figure out the period? Let's explore the method of getting period first. If you are given a function, then period equals 360 over b or 2 pi over b. If you are given a graph, let's label the coordinate for A is x, capital M, and maximum. For B is x, lowercase m, and a minimum. Then the period equals 2 times the absolute value of x coordinate at maximum point minus x coordinate at minimum point. In other words, period is double the horizontal distance between two consecutive maximum and minimum point. For third one, word problem. Period equals value of independent variable for a complete revolution. For this word problem, since one complete rotation of a minute hand, value of independent variable theta equals 360. So period equals 360 and B equals 360 over 360 equals 1. In this way, we can figure out h of theta equals 12 cosine theta plus 16. Now let's go to C. Find the value of h when theta equals 160. Basically, we are looking for h of 160 equals. Go to calculator. When we go to calculator, let's set up the window. X minimum 0. X maximum will be period. Period is 360. So scale of X equals 360 divided by 10, 36. Y minimum, let's use 0 because minimum is 4. Y maximum, we are given 28. So you can use 30, 40, 50, it's really up to you. Let's use 30. Then Y scale equals 30 divided by 10, 3. Let's go to calculator. Click on tab. F1 of X equals 12 cosine. Change theta into X plus 16. Enter. Change window. 0, 360. Scale is 36. Y minimum 0. Maximum, let's use 30. Scale 30 divided by 10 is 3. Enter. We are looking for h of 160. Let's use trace to figure this out. Menu 5. Enter. Put 160 here. Enter. They give you answer 4.72 directly. So for C, h of 160 equals 4.72. D, find the domain and range of h of theta for 1 revolution of minute hand. For the domain, theta is greater than equal to 0, less than or equal to period 360. For the range, let's look at this clock. H greater than equal to 4, less than or equal to 28. E, find the value of theta when the height of endpoint of the minute hand above the bookshelf is greater than or equal to 20 centimeters. For 1 revolution of the minute hand, we will set up the inequality h of theta greater than or equal to 20. We will solve this by graphing. Click on tab. F2 of X equals 20. Enter. We need to figure out these two intersections. Menu 6, 4. Menu 6, 4. H of theta greater than or equal to 20 means this part of a graph and also this part of a graph will be the solution. Let's check the domain from 0 to this 70.5288 or from 289.471 to 360. Let's use interval notation to write down the solution. Inclusive of 0 to 70.5. Inclusive. Union inclusive of 289 to 360 inclusive. Or you can write down theta greater than or equal to 0, less than or equal to 70.5. Theta greater than or equal to 289, less than or equal to 360. The height g centimeters of endpoint of the hour hand above the bookshelf is modeled by function g of theta equals negative a cosine theta over 12 plus b, where theta is the angle in degrees rotated by minute hand from 6 a.m. Write down the amplitude of g of theta. Amplitude will be the distance from midline to the maximum or from midline to the minimum. It's a radians of this clock face. Our hand is 12 centimeters. So 12 is the answer. Write down the equation of principal axis g of theta. This is a midline. 12 plus 4 equals 16. So you can write down y equals 16 or g of theta equals 16. Let's go to H. Find the value of period of g of theta. For the period, since we are given the coefficient of theta, we can use the formula period equals 360 over b. This b equals 1 over 12. 360 over 1 over 12 equals 360 times 12 equals 4,320. I. The endpoints of minute hand and hour hand meet when theta equals k. Find the smallest possible value of k. We will set up h of theta equals j of theta. We already figured out h of theta equals 12 cosine theta plus 16. G of theta equals negative 12 cosine theta over 12 plus 16. Let's go to calculator. Click on tab, upper arrow. We will put G of theta into F2 of x, negative 12 cosine, control divide, x divided by 12. Remember, you have to change all the variable into x when you graph the function, plus 16. Then enter. You could see we have two intersections. We are looking for the first intersection. Menu 6, 4. 166 will be the solution. Since we are looking for the smallest possible value of k, the first intersection is the smallest possible value of k. So k equals 166.